Hi students, good morning to all of you. Hope you are all doing good. Welcome to lecture 7 of Quadratic Expressions. Hope you have reviewed all the previous 6 lectures in this particular topic. So in this lecture, we'll be discussing some problems on quadratic inequalities and you'll be introduced to a graphing calculator called Desmos, which will be very helpful in sketching some curves and sketching some inequalities. Let us solve a quadratic inequality. Here is an inequation being given. Solve the inequation root of x plus 2 greater than root of 8 minus x square using algebraic method. Okay, let us see how to solve this. Okay, let me write the solution here. See, remember, whenever an inequation of this type is given, you will be getting at least 2 to 3 simultaneous inequations, quadratic or linear, whatever it is. You will be getting at least 2 simultaneous inequations. So what are the simultaneous inequations to solve the given inequation? Let us see here. Okay, of course you remember this function root, under root there is a function, under root there is a function. Okay, this root x plus 2 is defined if and only if x plus 2 must be greater than or equal to 0, implies x is greater than or equal to minus 2, implies x belongs to the interval minus 2 to infinity. Okay, we have discussed this point before. Under root, a function is defined if and only if f of x is greater than or equal to 0. Now you have got the second function, 8 minus x square is defined. Okay, if and only if this 8 minus x square must be greater than or equal to 0, implies minus of x square minus 8 must be greater than or equal to 0. If at all we multiply with this inequality, we get x square minus 8 less than or equal to 0. Okay, now this x square minus 8 can be written as x square minus 2 root 2 whole square less than or equal to 0. So this can be written as x minus 2 root 2 into x plus 2 root 2 less than or equal to 0. The solution for this quadratic inequation is x belongs to the closed interval minus 2 root 2 to 2 root 2. Here we have written closed interval because of the inequality sign. Okay, hope you have understood this. Now let us get the third inequality. So it is given that root of x plus 2 is greater than root of 8 minus x square. So if these are positive numbers, we have discussed the result already. If these functions are positive, then we have x plus 2 greater than 8 minus x square. The reason is both the functions x plus 2 greater than 0, comma 8 minus x square greater than or equal to 0. Okay, we have discussed this point earlier. Now let us rearrange this. Okay, we get this is x square plus x minus 6. I am bringing all these terms this side. Minus 6 is greater than 0. So this is x square plus 3x minus 2x minus 6 is greater than 0, and this can be written as x into x plus 3 minus 2 into x plus 3 greater than 0. So this implies x plus 3 into x minus 2 is greater than 0. Okay, so what is the solution of this inequation? Implies x belongs to the interval minus infinity to minus 3 union 2 to infinity. Okay, now we have got these three inequalities. Now, in order to find out in order to solve the given inequality, given inequation, we have to solve three simultaneous inequations. So in this case, what are the inequations? The first inequation is x plus 2 greater than or equal to 0, for which you know the solution. X belongs to the interval minus 2 to infinity. What is the second inequality? 8 minus x square greater than or equal to 0. We have seen the solution here. It is minus 2 root 2 to 2 root 2. And the third inequality that we have seen is x square plus x minus 6 greater than 0 implies x belongs to minus infinity to minus 3 union 2 to infinity. Now, what is the solution set here? The solution is the intersection of all these sets. Okay, the intersection of minus 2 to infinity intersection minus 2 root 2 to 2 root 2 closed interval intersection. This is minus infinity to minus 3 union 2 to infinity. Let us see what is the solution. Let us find out with the help of a diagram. Let me draw a real number with the help of a real number line. Okay, I have drawn a real number line here. Here I have indicated these numbers. So I am indicating these numbers. It is minus 2 here, minus 3 here, and here I get minus 2 root 2. And for the right side, I have 2 and I have 2 root 2. This will do my job actually. Okay, now let me shade the regions. So first one is minus 2 to infinity. So minus 2 to infinity, I am shading it now. So minus 2 to infinity. So minus 2 to infinity, I have shaded. And next one is minus 2 root 2 to 2 root 2. So let me shade this minus 2 root 2 to 2 root 2. So this will end up here. Okay, now I'll use the next one. That means I'll shade this part minus infinity to minus 3. So minus infinity to minus 3 is this one, and 2 to infinity means 2 to infinity. So from this part it will shade. Okay, now you can see where all the three colors are visible. Okay, all the three colors are appear here. This is that region. Okay, so what is it? This is 2 and this is 2 root 2. So what is the solution? It is open 2 to 2 root 2. Okay, that is, here is the solution. So the solution for the given inequation is solution of the given inequation is open to root 2. Why it is open root 2 closed to root 2. So you just write closed. So why it is open? Because here 2 is open. So all the three equations must hold simultaneous. These are the three simultaneous inequations we have to solve in this particular inequation. Okay. Hope you have understood the solution. Let us solve one more inequation. Here is the question. Solve the inequation under root minus x square plus 6x minus 5 greater than 8 minus 2x using algebraic method. Okay. Now let us write down the solution for this. Solution here. So what usually we will do, like in the previous problem, anyway, under root some function is there, this must be greater than or equal to 0, and we are going to square it. We are going to square it. So before squaring, one has to be careful because we cannot square it directly because you don't know what is 8 minus 2x, whether 8 minus 2x is positive or negative. So 8 minus 2x take both positive values as well as negative values. So you will be able to square only when this quantity is positive. So that's why here arises two cases. There are two cases. There are two cases here. There are two cases in order to solve the given inequation. So case 1, 8 minus 2x is greater than or equal to 0, and case 2 is 8 minus 2x is less than 0. It is less than 0, let us take. Okay. Now we will solve case 1. In case 1, solve the inequation in case 1. So case 1 is 8 minus 2x is greater than or equal to 0. In this case, let us try to solve the given inequation. In any case, root of minus x square plus 6x minus 5 is defined if and only if minus x square plus 6x minus 5 is greater than or equal to 0. Throughout multiply by minus, I will be getting x square minus 6x plus 5 less than or equal to 0. This can be factorized as x minus 1 into x minus 5 less than or equal to 0 implies x belongs to 1 to, it is 1 to closed interval 1 to 5. Okay. Now it is given that root of minus x square plus 6x minus 5 greater than 8 minus 2x. Since we are taking 8 minus 2x positive, squaring is allowed here. Upon squaring both sides, we get, what do we get? Minus x square plus 6x minus 5 greater than 8 minus 2x whole square. So this implies minus x square plus 6x minus 5 greater than 64 plus 4x square minus 2 into 2 4 32. This is 32x. So this implies upon rearranging the terms, I get 5x square here minus 38x plus 69, okay, less than 0. So before proceeding further, let me check the determinant of this inequation. Let me take the determinant of this expression. So delta is equal to minus b minus 30a, sorry, b square minus 4ac minus 4 into 5 into 69. So 38 square is 1444 minus 1380. This is 20 plus 44, 64 is positive. So implies roots are real. Roots are real. Now we have to solve for those roots. The solution continues here. Solution continued. So we are in case 1. Case 1 is 8 minus 2x is greater than or equal to 0. Okay. Now what did we get here? We have got 5x square minus 38x 38x plus 69 is, what is there here? Plus 69 less than or equal to less than 0. Okay, let me factorize it. So 5x square minus 69 into 3, 69 into 5, it is 23 into 3 into 5, so 23 and 15. Okay, so this is minus 15x minus 23x plus 69 less than 0 implies 5x. If I take common, it is x minus 3 minus 23 into x minus 3 less than 0 implies, so x minus 3 into 5x minus 23 less than 0. So this implies, where does x belongs to? X belongs to the interval 3 to 23 by 5. Okay, now we have got 3 inequalities here. Let me solve it here. So we have got 3 inequalities. So what is the first inequality? 8 minus 2x greater than or equal to 0 implies x is less than or equal to 4. And the second simultaneous inequality is, this must be minus x square plus 6x minus 5 is greater than or equal to 0 implies x belongs to the interval minus 5 to minus, sorry, 1 to 5 closed here. And the third one is, upon squaring we have got this inequality, that is 5x square minus 38x plus 69 less than 0. So implies x belongs to the interval 3 to 23 by 5 actually. Now with the help of a real number line, we'll be able to find out the solution for it. So let me indicate all the numbers that I have. So is equal to 4. So you have 4 here. You have any other big number? Yes, 5. 5 is there. And the next number is 23 by 5. Okay. You have this 23 divided by 5. And you have 1. You have 1 here. And you have 3 also. So these numbers are being indicated. Now let us find out the solution for it. So x less than or equal to 4. X less than or equal to 4 means what? So I have to shade this region. Okay, and x belongs to 1 to 5. Let me take other color. So 1 to 5. So 1 to 5. So till here. And the third one is 3 to 23 by 5. So 3 to 23 by 5 is 3 to 23 by 5. I am shading it here. Okay. Now if you see carefully, you have the three colors coincide only at this particular point. Okay, in this particular region actually. So this is the region that I am indicating here. So here you find all the three here. So what is the answer? Answer is 3 to open, 3 to closed, 4 actually. 4 is allowed actually. So 4 is there. So the solution in case 1 is interval open 3 to closed 4. Okay. Now let us solve the same. Let us solve case 2 now. Case 2. Okay, let me write it here. Case 2 is what actually? So 8 minus 2x is less than 0. Okay. Now we have this inequality minus x square plus 5x minus 6 greater than 8 minus 2x. So this is a positive quantity. This is, if at all, in this case 8 minus 2x is negative. All positive quantity is greater than always a negative quantity. So minus x square plus 5x minus 6 greater than or equal to 0 implies x belongs to the closed interval 1 to 5. Okay, 8 minus 2x less than 0 implies 2x is greater than 8 implies x is greater than 4. So, and this is true always, because this is negative quantity and this is a positive quantity. And the positive quantity is always greater than a negative quantity. So the solution in this case is, that's why you cannot even square it, because this particular term is positive and this particular term is negative. You cannot square it. Okay. Now the solution is, we have to take the intersection of closed interval 1 to 5 intersection. Okay, it is not intersection. It is open 4 to infinity. So that is equal to what? So here you have, okay, here you have 4 to 5 closed actually. So 4 to 5 closed. Okay. Now solution is in case 2. Okay. Now the solution set for the given inequation. So the given inequation is solution in case 1 union and the solution in case 2. So you may get a doubt that why I have taken union instead of intersection here, because these are two different cases, one case 1 or case 2. That's why you have to take the union of it. Okay. Now, what is the solution in case 1? Case 1, the solution is open 3 to closed 4. Okay. Union, here it is 4 to closed 5. So this implies the solution of the given inequation is, what is the union of this one? It is open 3 to closed 5. Okay. So hope you have understood. Whenever you get two cases, the solution you have to take union actually. Okay. So whenever you are having cases, you have to be little careful here, like in this problem. Hope you have understood the problem. Let us solve one more problem on quadratic inequalities. Here is our problem. Solve the inequation under root 6 plus x minus x square divided by 2x plus 5 greater than or equal to under root 6 plus x minus x square divided by x plus 4. Let us solve this problem. Okay. Let us write down the solution here. Okay. So usual practice is the first there is a under root function. So 6 plus x minus x square is defined if and only if 6 plus x minus x square is greater than or equal to 0. So here for information, 6 plus x minus x square can be factorized as 2 plus x into 3 minus x. Okay. So here 6 plus x minus x square is greater than or equal to 0. If at all it is equal to 0, this is 0, this is 0. So quadratic inequality is satisfied. If it is greater than 0, something else happens here. So that's why we split this problem into two cases. So case 1. So case 1 is what? 6 plus x minus x square greater than 0. And case 2. Case 2 is 6 plus x minus x square is equal to 0. Now let us solve this problem in case 1. Okay. Case 1 we will solve. Okay. So since 6 plus x minus x square greater than 0, this implies this is equal to x plus 2 into 3 minus x is greater than 0. We have seen a property regarding this. This implies x belongs to minus 2 to 3 actually. Okay. So, and let us get back to the inequality. Now, under root 6 plus x minus x square divided by 2x plus 5 greater than or equal to under root 6 plus x minus x square divided by x plus 4 implies, as this is not equal to 0, these two gets cancels actually. Okay, these two get cancelled because 6 plus x minus x square is positive. Okay. Now this is 1 divided by 2x plus 5 greater than or equal to 1 divided by x plus 4. So with the property of real numbers, 1 by a greater than or equal to 1 by b implies a is greater than, that is 2x plus 5 is less than or equal to x plus 4. The inequality reverses actually. Okay. So what is the solution here? So this is equal to 2x minus x is x and less than or equal to minus 1. So we have got one more inequality here. So in the case 1, we have got two inequalities, namely inequality 1 and inequality 2. Okay. So both the inequalities holds true. The solution of both inequalities, So let us try to understand with the help of real number line. Let me draw a real line indicating these numbers. This is 0, let us say. This is minus 1, and here you have minus 2, and here you have 3 actually. Now let us indicate the solution minus 2 to 3. So minus 2 to 3 means, so this region I am shading it. Okay. Now x is less than or equal to minus 1. X is less than or equal to minus 1 means it is this portion. Okay. So what is the common region here? This is the common region. So where does x belongs to? X belongs to minus 2 to minus 1 closed. Okay. So the solution of both the inequalities 1 and 2 is, okay, x belongs to the interval minus 2 to minus 1. Minus 2 open, closed, minus 1. Now let us discuss case 2. Case 2 is continued here, or the problem is continued here. Problem continued here. Okay. Let us discuss case 2. Case 2 is what? 6 plus x minus x square is equal to 0. In this case, the above inequality holds true. Above inequality holds true. And for what values of x actually? So x is equal to minus 2 comma 3. Okay. So the solution in case 2 is x is equal to minus 2 comma 3. Now the solution of the overall inequation, or the given inequation, is equal to solution in case 1 union solution in case 2. Okay, even in the last problem also we have solved the inequality by cases. Solution in case 1 is what? Minus 2 to minus 1, open at minus 2, closed at minus 1, union, this is the set, minus 2 and 3. So this can be written as minus 2 to minus 1 union 3 here. Okay. So this is the final solution. The solution is closed interval minus 2 to minus 1 union 3 actually. Okay, hope you have understood the solution. Okay, go through it once again. If you have any doubts, get back to me. Let us discuss one more inequality. Here is our problem. Solve the inequality under root 3x minus 8 less than minus 2 here. Let us solve this solution. Okay, here is the solution. Let me change the color. Right. Solution. Let us write it here. So, in all these problems, whenever you find a function under root, okay, so here also you have a function which is under root 3x minus 8 is defined if and only if this 3x minus 8 must be greater than or equal to 0 implies x is greater than or equal to 8 by 3. Okay, now we know that under root 3x minus 8 is positive quantity or greater than or equal to 0, but and minus 2 is negative. So for the given inequation to satisfy what is that, what should happen, this under root 3x minus 8 must be less than 2, must be less than 0. So this 1 and 2 contradicts, 1 and 2 are contradicting to each other. Why? Because on one hand it is telling that this quantity is greater than or equal to 0. In order to get a solution for this inequality, this quantity must be less than minus 2, that is less than 0. So at the same time, a quantity cannot be greater than or equal to 0 or and less than 0. So this is a contradiction. That means what? No real value satisfy the given inequation. So no real value satisfy the given inequation means what is the solution set? So the solution set is equal to 5. That is the null set actually. Okay. Now let us solve one more miscellaneous problem. So here is the problem. If both the roots of the quadratic equation x square minus 2x plus k square plus k minus 5 is equal to 0 are less than 5, then find the possible values of k. So there is a question given based on this problem in the assignment. Okay, so now this problem will help you to solve the problem given in the assignment actually. Okay, let us try to solve this problem. Solution. So in the given problem, it is given that this quadratic equation has roots. Okay, now let alpha comma beta be the roots of the quadratic equation x square minus 2x plus k square plus k minus 5 is equal to 0. Given that the roots are less than 5, this implies alpha comma beta are less than 5. This is the information that we have. Now we have to find all the possible values of k actually. Okay, now let me draw a real number line, okay, indicating alpha and beta and phi here. Okay, this is how they are located. Assuming without loss of generality, alpha is less than beta. Okay, so this is how the numbers are located. Now, this quadratic inequation has real roots and alpha comma beta is less than 5. Okay, so let me take this as f of x. Okay, now we know the where in which region f of x is positive and in which region f of x is negative. Okay, and you know very well that in this region f of x and the leading coefficient take the same sign. So what is the sign of the leading coefficient here? Leading coefficient is 1. So here leading coefficient is 1. Leading coefficient is 1, which is positive. So this implies f of x is also positive in this region. Similarly, f of x is positive in this region also. Okay. Now, in this region, what happens? In this region, f of x will be negative. Now, phi belongs to which region? Phi belongs to the region, or phi belongs to beta to infinity. This implies f of phi must be greater than 0. Okay, because it is in this region phi is located. So this implies what? F of phi. So it is phi square minus 2 into k into phi plus k square plus k minus phi greater than 0. So this implies phi square. This is k square minus 10k plus k. So it is k square minus 9k plus 20 greater than 0. So you can factorize it as k minus 5 into k minus 4 greater than 0. So what is the solution for this? K belongs to minus infinity to 4 union 5 to infinity. Okay. So these are the possible values of k are the possible values of k are minus infinity to 4 union 5 to infinity. Hope you have understood this problem. With the help of this problem, you can answer some problems given in the assignment actually. Okay. Hope we have solved enough number of example problems in these lectures. Now there is an assignment given which comprises of 20 questions. Please try to solve those assignment problems. If you get any doubts in these lectures or any doubts in the assignments, please do get back to us. Okay. As a last concept, I would like to introduce you a graphing calculator called Desmos through which you can sketch the graphs. This is Introduction to Desmos Graphing Calculator. So in order to get Desmos calculator, graphing calculator, so get into the Google page and type Desmos, and in the first link, under the first link, you can see graphing calculator. Just click on that. You will be landed in the home page of this Desmos. This is how the home page of Desmos looks like. So here is the space to give the mathematical expressions. Okay, now let me give a mathematical input. F of x is equal to the function I am giving. F of x is equal to x square, let us say. Now you can see, you can get the graph of f of x is equal to x square, or simply y is equal to x square, and the color of the graph also you can see here. Now let me give one more graph. G of x is equal to x plus 2, let us take. So x plus 2 is y is equal to x plus 2. Now you can see a blue line here. This is how you can distinguish the graphs of two given functions. The first one is red color and the second one is in the blue color. Okay, this is how you can distinguish between the graphs of two different functions. Now, in the previous lectures, I have discussed the graphical transformations of y is equal to x square. Here I would like to illustrate those examples so that you can have a better understanding about the graphical transformations. Let me start with g of x is equal to ax square. Okay, now here, and we have seen in the lecture for different values of a, we have plotted different curves actually. This is actually called a parabola. Okay, now I am adding a slider. Adding a slider means I can keep on changing the values of a. I need not give 1, 2, 3. Now with the help of this slider, I can change the values of a actually. Now you can see the what is the value of a it is taking. So the graph of g of x looks in the green color. Okay. Now let me change the value of a, and accordingly how the graph of g of x changes, let us see. Now I am changing the value of a to 1.5. Now you look at the graph of g of x. So that is g of x is equal to 1.5 into x square. Now it is actually shrinking. Okay. Now let me take it to 2. Let me to, and it is much more. It is shrinking some more. Okay. Now let me change the values of a further. Then what is happening is it is shrinking actually. It is shrinking from the original graph. Let me take back to a is equal to 1. Now let us move left to a is equal to 1. Okay, then what happens? Let us see. Now you can see the green color graph is stretching, is going away from the red color graph. F of x is equal to x square. Now I keep on changing the values. Okay, now I am giving 0.6. Now I am giving 0.4. Now I am giving 0.3, 0.2. It is bulging actually. The graph is expanding. Now if it is 0.1, it is stretching lot more. Then finally, if it becomes 0, then there is no graph because g of x is equal to 0, no graph. Now let me go negative side. So minus 0.1 means it is just the reflection of the above graph. Now similarly, whatever happened here in the upside, the same thing happens in the downward direction also. Okay, this is how the graph looks like. After crossing minus 1, it is going to shrink, and between minus 1 to 0, it is actually bulging actually. Okay, expanding. Okay, so this is one graphical transformation. Now let me take another graphical transformation. So g of x is equal to, or I'll write y plus k is equal to x square. Okay, I'll add 1 minute. Y plus k is equal to x square. Right. Let me give my input as g of x. Right. So g of x I am giving as an input. Now I'll take the slider as k actually. Okay. Okay, now let us try to understand the graphical transformation y plus k is equal to x square. So what am I doing is g of x is equal to x square minus k. Let us take. So it is nothing but y plus k is equal to x square. Okay, it is nothing but y plus k is equal to x square. Now let me change the color of the graph. here I am taking this orange color graph, okay, for g of x. So g of x is equal to x square minus k, and k values are from, so k values I'll take it as h whole square. Okay, now I'm going to add a new slider k. I am cancelling it out. So here the graph of g of x is in the orange color, and the h value I am varying actually. See, if I change the h values, what is going to happen? Let us see. So h is equal to, right now my h value is equal to 1. Now I'll increase it to 2. Now I'll increase it to 2, 2.1. Okay, 2 I have increased. Then the graph has started moving in the left direction. Now similarly, if I keep on changing, keep on increasing the values, the graph is translating in the left direction horizontally. Now let me decrease the values. It is coming to the original position at h. When h becomes 0, actually it coincides with y is equal to x square graph. Okay, now I'll move to left in the left direction. Then what happens? If the h values are getting decreased, or are becoming negative, then it is, the graph is moving in the right direction horizontally. Okay, so this is how the graph translates vertically, horizontally, and h comma k values changes actually. Okay, this is the third graphical transformation. Now let us try to understand all the three simultaneously. Now I am going to give f of x is equal to ax square plus bx plus c. Okay, now I am changing all the values actually. A also I am adding a slider, b also I am adding a slider, and c also I am adding a slider actually. Okay, okay, now let me change it. Right. Okay, so I am adding a slider actually, so its value square. And we have discussed this problem. Now I would like to find out when does this f of x is less than 0. I would like to sketch f of x less than 0. So how do I give that input? Let us see. So f of x must be less than 0. You write type f of x here, and less than all those y values less than 0. Okay, so this is how you can sketch actually. So if you click on this point, you will get this point. You can label this point actually 3 comma 0. So you can even label this. Now what about this point? This point is 7 comma 0. So this point also I am typing it here. I can label it actually. Okay, so this is how one can sketch an inequality. Okay, now let me take two inequalities. In addition to the above, I'll type one more inequality, x square 2 minus x. So this is one function. Let me take g of x is equal to, so here g of x I am giving as square root of, yeah, here the square root of 4x square plus 12x plus 2 comma 0. I am typing it here, and I can label it here, and 3 comma 0 also I can label it here. Okay, so this is how, and these are the values. So below this shaded region, what are all the values of x for which the given inequality holds true? This is how one can find out the solution from this graphing calculator. Okay, let me give one more example. So f of x is equal to square root of x plus 2 actually. Square root of x plus 2 I can select here. So x plus 2 here. Okay. Now g of x is equal to under root 8 minus x square. Okay, this is how the graphs of these two function looks like. Okay. Now what is that you have to find out is find the values of x for which f of x is greater than g of x. Now what you have to do, f of x, you have to type less than, f of x is greater than, right? F of x is greater than. So f of x is greater than y greater than g of x. Okay. So it is in this region the given inequality holds true. Now you click on this point. So corresponding x value is somewhere here. Okay. So from here to what is the corresponding value here? So it is 2 point something. It is okay. This is 2.828. This is actually 2 root 2. So this is 2 comma 0. This is 2 comma 0. So this is where it looks like. And the 2 under root 2. So it is 2 into under root 2 comma 0 actually. So add this to the label and you can see between these two values, okay, the given function is the given inequality got satisfied. So this is how we can find out the solutions of the inequality easily. Now let me discuss the last example. So the last example is minus x square plus 6x minus 5. Okay, and g of x I am taking as 8 minus 2x. Okay, I am deleting all these things. So in the problem we have been asked for what values of x is f of x is greater than g of x. So f of x greater than y greater than g of x. Okay, now you can see what is happening. So it is in this region. Okay, the above inequality holds true. Now click on this. So this is 3 comma 2. So correspondingly we are locating 3 and here what is the value? 5. Okay, so I am typing 3 comma 0 and I can label it here, and similarly 5 comma 0 also I am labeling it here. Okay, so it is in this region. Okay, for these values of x. Okay, for those values in between 3 and 5 the given inequality holds true. Okay, so with the help of a graphing calculator we can sketch some regions and we can solve even some inequalities. So whatever the problems, whatever the inequalities you come across, so after doing all the calculations you can verify with the help of a graphing calculator. So there is a Android app for Desmos. In the Play Store you type Desmos, there will be an app called Desmos graphing calculator. You click on, you install it, and you can start using the same. So this app could be better, this app is better in visualizing the graph. Okay, now here if at all you want to take the image of it, you can click on share, so export image. So export image means now there might be different options, there will be different options here. You click on something, okay, and medium, so this is where you can get the graph section. Okay, the graph is downloaded. So with the help of this graphing calculator only, I could collect the images which I have placed in the PPTs. Okay, hope you have some experience, good experience with the graphing calculator. Okay, thank you.